Hello maths fans, going to look at Indices 1 and Indices 2 from MyiMaths here. So this is applying the rules of indices, the laws of indices. Now the first law is that when we multiply powers of the same base, so in this case the base is 3, the power is 2, when we multiply powers of the same base we add the powers. So this one becomes 3 to the power of 2 plus 6 is 8. Pretty straightforward, all of those dead easy. Dividing, the rule is we subtract the powers. So if we've got the same base, we're going to subtract the powers. So in this case, 6 minus 4 is 2, so we get 6 squared as the answer there. That's pretty straightforward. Moving on to the second part of Indices 1, we are raising a power to a power. Now when you raise a power to a power, we're going to multiply the two powers. We're going to multiply. So 3 times 2 is 6. This results in 4 to the power of 6. All of those are dead easy. When we get over here, a couple of things to spot. If you see the number on its own, that's kind of like 14 to the power of 1. Might help you to just put in that 1 there and then apply the rules as the same. So when we're dividing, we subtract. So this is going to be 14 to the power of 7 minus 1 is 6. All right. Same with this one. Imagine that's a 1. E to the power of 4. Well, that means e times e times e times e. Multiply it by another e. We've got e to the power of 5. But again, if you write in the power of 1 there, it's pretty easy to solve that problem. Anything to the power of 0 is 1. So 0 times 4 is 0. N to the power of 0 is 1. Down here, do the top part first. X to the power of 3 times x to the power of 6 is x to the power of 9. X to the power of 9 divided by x to the power of 9. Anything divided by itself. What's 100 divided by 100? What's 5 divided by 5? It's 1. All right. Moving on to Indices 2 now. Indices 2, we're talking about the negative indices. Now, the thing to remember with negative powers is you just basically write 1 over, and then you use the positive power. 1 over 3 to the power of 6. 1 over x to the power of 3 in this one. So as soon as you see that negative, write 1 over, the reciprocal of that number. Coming over to some of these ones, let's do the last one here. So we're going to go 1 over 4 to the power of 4. Well, we need to know what 4 to the power of 4 is. 4 times 4 is 16. Times 4 again is 64. Times 4 again is, I think, 256. So this is 1 over 256. That's all there is to that. Now it gets a little bit more interesting and a little bit more tricky. So we've got now some expressions with coefficients. So we've got a base of x, but then we've got a coefficient in front as well. So the laws of indices are still true, but you've got to be a bit careful about how you apply them. So in this case, we still multiply the powers of x, and we get 2 plus 7 is 9. And then imagine this is 1x. We're going to do the 6 times the 1 as a normal multiplication. 6 times 1 is 6. Let's look at this example. 2 times 6 is 12. E to the power of 6 times e to the power minus 4. Add the powers, so we're going to get 2. When we're dividing, again, the same thing happens. I like to sort of write these ones 6a to the power of 8, and then write it as a sort of fraction like this. I find it easier to recognize what's going on. Divide the numbers as normal. 6 divided by 3 is 2. When we're dividing powers, we subtract. So we're going to get a to the power of 3. 2a to the power of 3 in that example. Okay, so the coefficients you divide as normal. The powers, when we divide, we subtract. So make sure you're just separating the coefficients from the bases, if that makes sense. Let's look at raising a power to a power when we've got coefficients. Here, I need to do 3 to the power of 4 as normal. So 3 times 3 is 9, times 3 is 27, times 3 is 81. if you can type it in your calculator, no problem. 3 to the power of 4 is 81. Then m to the power of 4 to the power of 4, when we're doing a power to a power, we multiply. So 4 times 4 is 16. Okay, so make sure if the base, you raise it to the power, if the coefficient you raise to the power to the power you multiply. So a couple of things to just be a bit aware of there. Let's have a look at this very last question, and if we can do this one, we can do anything. So we've got 12t to the power of 5 times 4t cubed squared. Let's start by multiplying out this power. This is going to become t to the power of 6, and then 4 squared is 16. So that one there, we can change for 16t to the power of 6. Now let's do all of this top part. 12 times 16, 10 times 16 is 160, 2 times 16 is 32, 160 plus 32 I think is 192, so we're going to get 192, t to the power of 5 times t to the power of 6 is t to the power of 11. Then we're going to divide that by 12 t to the power of 6. How many 12s go into 192? You can use your calculators if you want. 12s into 19 go 1, remainder 7. 12s into 72 go 6, so it's 16. So we divide the numbers as normal. 192 divided by 12 is 16. And then we subtract the powers when we divide. 11 minus 6 is 5. Hopefully that's all made sense. Go give it a go. Get 100%.